You'd think, or at least I think, that everybody in the food business would know these temperatures, but in my classes I find they don't. Now, not all cooks are still cooking, but still, it seems like they ought to know that. So let's assume they don't know that. Let's assume your people don't know that either. And so I would post these, get them laminated, put them on the oven so that the people know for sure what temperature it's supposed to be. So, poultry leftovers and stuffed meats get cooked to 165. Ground meat and needle tenderized beef get cooked to 155. Eggs, fish, beef, and pork get cooked to 145, and all of those are for 15 seconds. And rare roast beef or pork gets cooked to 130. If you do that, however, you need to keep it at 130 for 112 minutes, at which point I guess the bacteria just give up and die. So 112 minutes at 130 degrees. So you'd need a special oven for that. You couldn't do it in a regular oven. I think it would dry out. So you'd need like a Eloma or Rational or Alto-Shaam type oven where you can put product in. It'll hold at that temperature without drying up. So why do these temperatures differ? Do beef bugs die at a different temperature than poultry bugs? No. The difference is that poultry, by the nature of the beast and the way they're raised and whatever, tend to have more bacteria. So it's Las Vegas odds. The odds are there's more bacteria in poultry than meat, so we're going to cook to 10 degrees higher just to make sure we got them all. Leftovers, we had a couple of opportunities to mess them up, so we've cooked them, chilled them, reheated them, stored them somewhere for a while, so there's a good chance there's a lot of bacteria in there, so we're going to cook to 165. Stuffed meats, in the process of stuffing, there's all kinds of opportunities for cross-contamination when combining the two products and the work that goes into that. Why ground meat and needle tenderized beef at 155, 10 degrees higher than if they were just plain beef. When you grind the meat, what are you doing? You're taking the warmer meat from the outside, and which would have more bacteria, and you're spreading that throughout the product. The other thing is you're creating more air contact, and so the product's going to get warm faster. Same thing with needle tenderized beef. If you're not familiar with that, that's they call it a jacquard, which like needles that go through the beef to break down the tendons and make it easier to chew. And then 145 is everything not covered above. In microwave cooking, the heat is unevenly distributed. Therefore, we need to constantly rotate or stir, or rotate or stir midway through the cooking process. So, you know, with pizza they say stop cooking halfway through the time, turn it half a turn, and continue cooking. Why do we do that? Because the molecules from the microwave are not distributed evenly, and so we want to make sure that all parts of the product get cooked evenly. So that's why we're going to rotate in the microwave. All parts of all food, whether it's pork, beef, soup, I don't care if it's a peanut butter sandwich, if you're putting it in the microwave, it must be 165. Then foods must be allowed to stand covered for at least 2 minutes. Why is that? Actually, the heat will continue to rise while it's sitting there because the molecules didn't hear the ding go off, so they're still moving and still heating the product. And also you're going to spread that heat throughout the product, so it's make sure that the entire product gets cooked to the 165 temperature. Proper ways to cool. You need to cool from 135 whenever the food hits 135 degrees Fahrenheit down to 70 within 2 hours. Remember, that's the most dangerous part of the danger zone, 135 to 70. Then we need to get it from 70 down to 41 or below in 4 more hours for a total of 6 hours. If you've been around a while, you might know it as 2 and 2 for a total of 4, but in the 2009 Food Code they changed that to 2 hours to 70 and then 4 more hours to 41, so a total of 6 hours to get the product down from 135 to 41. Thick items like chili, you can put them in an ice bath to cool them down faster and stir to distribute the chilled part. You can also use the ice wands. And first thing to do is put them in a shallow pan. 2-inch thick pan for 2-inch deep pan for thick liquids like a chili. 3-inch pans for thinner liquid like a soup. Why do you put them in thinner? Because there's more exposure to the refrigeration and the air to chill it down. And then you can also add ice to the product. Maybe that doesn't make for a good recipe, but you'd have to, particularly if the question says if you're adding ice as part of the recipe. So like when you do Jello, you may put less water in the beginning and then add some ice to it, and some other products you might. Anyway, it's a food safety course, not a culinary course, so you can add ice to the product. Previously cooked and cooled potentially hazardous foods must be rapidly reheated within 2 hours to 165 degrees for 15 seconds using appropriate cooking equipment. So reheating is 165. No matter what the product is, you're reheating it, it's 165. Potentially hazardous foods must be reheated, may be reheated in a microwave to 165 and must be allowed to stand for at least 2 minutes. Food preparation equipment must be used to reheat foods. Steam tables and food warmers are not acceptable for reheating foods. I went to take over food service at a hospital once, and they had lunch ready to go and on the line at like 9:30 in the morning, and you know, the soups and various things like that they'd put on there. I guess they were cold. I don't remember, but I know they'd put them out there, and they figured that's going to heat it up. Well, it will heat it up to 135 anyway, but it takes too long. It's in the danger zone too long, so you can't use steam tables or food warmers, tilting skillets, or anything like that. For reheating, you need to use the same equipment that you would have cooked an item in, you use to reheat the food. For the hot holding temperatures, this is your 41 to 135, so that means that product must be at 135 or above to keep it out of the danger zone. Cooked foods must be at 135 or above. An exception is the roast beef or pork roast that was cooked to 130. That only has to obviously be held at 130, can't be held higher than it was cooked. And cold holding, all potentially hazardous foods must be held at or below 41. So when you're taking the test, remember, if it's hot, I don't care where it is or what it is, gotta be 135. If it's hot, well, not in the refrigerator, but if it's hot on the serving line in the food warmer, it's gotta be 135. And if it's cold, it's gotta be 41 or below. So let's just review the proper thawing practices. If I ask you what's the best way to thaw product, you thought about it ahead of time and you did it in a refrigerator. The second way to thaw would be under cool running water, cool and running, 70 degrees or below. Third way would be in a microwave, uninterrupted, meaning you either keep cooking it in the microwave, or you can thaw it in the microwave and then put it immediately into the oven. Or the fourth way would be in the oven. Proper cooking practices. What do we cook to 145? That would be eggs, fish, beef, pork. What do we cook to 165? That would be poultry, leftovers, and stuffed meats. What do we cook to 155? That would be ground meat, needle tenderized beef. How long do we cook them at that temperature? Hold them at that temperature. 15 seconds. For rare roast beef or pork, how long do we hold it at the proper temperature? 112 minutes. And what is the proper temperature? 130 degrees. Proper way to hold hot food is 135 or above. And cold food is 41 and below. Hard maple or other equally hard close-grained wood can be used for cutting boards and blocks, baker's tables, utensils, rolling pins, salad bowls, donut dowels, chopsticks, confectionery paddles, things like that. Mostly those would be used at places like the fancy places might use a wooden cutting board for the carving stations. Mostly we use the plastic. Copper and galvanized metals. Copper may not be used for acidic foods, foods that are below 6.0. Examples of acidic foods would be vinegar, fruit juice, wine, tomato products, pickles. You would not put them in a copper utensil. The galvanized metal may not be used for acidic food contact surfaces. What is galvanized metal? It's like kind of flat color like a garbage can. Acidic foods used with copper and galvanized metals can create a chemical reaction and contamination. Does that happen? Yes, it does. I remember a year or so ago reading about a kindergarten. The kid brought some juice in from home. They put it into a galvanized metal container, which you might have in some of the old schools. And about 60 kids got sick. Nobody died, but kids got sick. Hand washing sinks must be in all restrooms. Hand washing sinks may not be used for any food handling. None, never. You can never wash anything in a hand washing sink other than your hands, nor can you wash your hands in anything other than the hand washing sink. So you cannot wash your hands in the vegetable sink. Why? Because your hands are dirty. That's why you're washing them. Your dirt and bacteria will bounce off the walls of the sink, and then when you put some vegetables in there, they'll splash up, and you'll get cross-contamination. Hand wash stations must have an adequate supply of disposable paper towels or a forced air blower to dry your hands. And each sink must have soap available. Seems kind of logical, but how many times do you go into a restaurant and there's no soap in the bathrooms? At which point I usually march over and say, hey, where do you guys wash your hands? Oh, over there. Oh, okay, well, you don't have any soap. And paper towels, same way.